So here we have a 61.6 ohm resistor is connected in parallel with a 132.5 ohm resistor. This parallel group is connected in series with a 25.6 ohm resistor, and the total connection is connected across a 12.4 volt battery. We're going to be finding the current and the power dissipated in the 132.5 ohm resistor. So we're going to be calculating the equivalent resistance of the parallels. So that's going to be R1 and R2 here. So the RP is the resistance of the parallels. It's going to equal 1 over R1 plus 1 over R2 to the negative 1. And we can plug in our values here so that we get 1 over 61.6 plus 1 over 132.5, and these are going to be ohms because these are all resistance. And to the negative 1, we're going to get that equals about 42.04 ohms. And so now we can take the parallel and we can add R3 to get our total resistance, and so that is going to be the 42.04 ohms plus the 25.6 from our R3, and that is going to give us about 67.64 ohms. And so now we can use Ohm's law, which says that the voltage is equal to the current times the resistance, and that's going to be voltage in volts, current in amps, and the resistance in ohms for the units there. And so from there we can rearrange this so that I equals V over R, and we're going to be plugging in our R total here with our voltage. So we're going to get that 12.4 volts over 67.64 ohms, and we're going to get about 0.1833, and that's going to be amps. So now we can take the Ohm's law of the specific branch. Actually, first we have to find the volts of the parallel. So that's going to be Vp is equal to the total current times the resistance of the parallel, and we can plug in the numbers that we know there. So we get 0.1833 amps times 42.04 ohms, and that's going to give us about 7.71 volts for our parallel voltage. So now we could take Ohm's law for the specific branch, and we get that the charge is equal to the parallel voltage over the resistance of the specified. So we want 7.71 volts over 132.5 ohms, and that is going to give us 0.0582, and that's going to be amps, and that is going to be the current. So that's our answer for A. And we're going to use the power formula, which says that P is equal to the current squared times the resistance. And we can plug in the numbers that we know for that to say that the specific power of R2 is going to equal 0.0582 amps squared, and that is going to get multiplied by the 132.5 ohms, which is going to give us a power of about 0.448, and that's going to be in watts. And that's going to be our answer for the power dissipated in the 132.5 ohm resistor. Sorry if you couldn't see all that. But yeah, thank you.